Good day, everyone. Welcome to another exciting episode of our discussion, where we dive into the microscopic world that's making a massive impact on our lives. I'm your host, and today we're exploring the wonders of nanotechnology. So, what comes to your mind when you hear the word nanotechnology? For me, when I hear the word nanotech, images like this come to my mind. And this
Where'd that come from?
It's nanotech. You like it?
But what does nanotechnology truly entail? This brings us to our first burning question of the day. What is nanotechnology?
What is nanotechnology? Nanotechnology is one of the biggest back of the world just because of articles. They studying about the biology, science, technology, and there's our medicine and for aircraft. So here they are the factors of the nanotechnology, one of the weapons, and then medicines. They are factors of nanotechnology, and especially now this generation is full of advantages about technologies that we include our society and our economy. So that's it all, and I hope that you learn about nanotechnology.
Thank you, Lagamon, for that insightful explanation. Now, let's scale down our perspective even further. Imperial, could you enlighten us on just how a small nanoscale really is?
Good day everyone, today I'm gonna discuss how small is nanoscale. Nanoscales refers to an extremely small size range of 1 to 100 nanometers. So that's the size of a nanoscale or nanoparticle. To put it into perspective, a nanometer is 1 billionth of a meter, which means in 1 meter, there is a billionth of nanometers, which is incredibly tiny, right? So here is some examples.
Fascinating. With dimensions that tiny, one wonders how we can even see these materials. Lozano, please share with us, how do we view nanomaterials?
In addition to what have been said, nanomaterials is very small that can't be seen in our very own eyes. Atomic force microscope, a type of high-resolution scanning probe microscope that has a resolution that you can measure in fractions of a nanometer, was pioneered in 1986 by Nobel Prize winner George Binig along with Calvin Quate and Christoph Derber. Scanning tunneling microscope, an instrument for imaging surfaces at the atomic level. Its development in 1981 earned its inventors George Binig and Heinrich Rohr at Nobel Prize in Physics in 1986.
Incredible technology indeed. Now, moving from observation to creation, Levitos, tell us about nano manufacturing. What is it and how does it work?
Nanomanufacturing refers to scaled up or the increased size of number or something, reliable since using nanotechnology in materials can be stronger and durable, cost-effective as it produces good results for the money spent. It also involves research and incorporation of process for the construction of materials which led to the development of new products and the improvement of materials. There are two fundamental approaches in nanomanufacturing. First, we have top-down approach, which is the breaking down of larger materials into nanoscale. This process needs larger amount of materials and discard excess raw materials. And lastly, the bottom-up approach with manufacture, products by building them up from atomic and molecular scale components. Example of top-down approach is the deep bend lithography, a method in which the tip of an atomic force microscope is dipped in a chemical fluid and then utilized to write on a surface, like an old-fashioned ink pen onto paper. Next is nanoimprint lithography, a method of generating nanoscale attributes by printing or stamping them onto a surface. For bottom-up approach, we have self-assembly, an approach wherein a set of components join together to mold an organized structure without any human intervention.
The potential seems limitless. Hangad, let's explore those possibilities. What can nanotechnology do for us today?
What can nanotechnology do? Materials characteristics such as their color, strength, conductivity, and reactivity can differ substantially between the nanoscale and the macro. Carbon nanotubes are 100 times stronger than steel but 6 times lighter. The tensile strength of carbon nanotubes is approximately 100 times greater than that of steel of the same diameter, having the potential to increase the efficiency of energy consumption, help clean the environment, and solve major health problems. Medical application. Nanoparticles are being developed for targeted drug delivery, which could revolutionize cancer treatment. These particles could deliver drugs directly to cancer cells, reducing the harm to healthy tissue. Other one is cleaner energy. Nanotechnology is being used to develop more efficiently solar cells and batteries, which could help us move towards a more sustainable energy future. And massive increase manufacturing production and significantly reduce cost. Products of nanotechnology will be smaller, cheaper, lighter yet more functional, and require less energy and fewer raw materials to manufacture, claim nanotech advocates. Improved materials. Nanoparticles can be added to materials to make them stronger, lighter, and more durable, water-resistant, or self-cleaning. For example, nanoscale coatings can be applied to wind turbine blades to make them lighter and stronger, allowing them to generate more electricity.
With such advancements, it's exciting to think about local applications. Lamadora, what are the possible applications of nanotechnology in the Philippines?
First is medicine. Nanomaterials is mixed in the medicine to create effective medicine for fast healing. Then, it ensures the effective functioning of smartphones, laptop, medical equipment, and automotive systems. And nanotechnology helps to create chemicals to avoid pests to their plants.
Before I end this discussion, I would like to present the possible advantages and disadvantages of using nanotech. So, some of its advantages. First is nanotech offers the potential for new and faster kinds of computers. Nanotech can also lead to more efficient power sources such as advanced batteries and energy storage systems. And it enables precise drug delivery, targeted therapies, and diagnostic tools. Nanoparticles can be designed to detect and remove pollutants from water, air, and soil. And it can lead to cleaner and more sustainable industrial processes. Nanotechnology has also its disadvantages. Like for example, the widespread adoption of nanotechnology may disrupt existing industries. And nanotech also raises potential threats. For example, security. Nanoscale materials could be misused for harmful purposes like creating nanoweapons. When it comes to privacy, nanosensors might invade privacy by monitoring individuals without their consent. And concerns include toxicity of nanoparticles and unintended health effects. And the pervasive distribution of nanoparticles may impact ecosystems. And additionally, some nanomaterials exhibit unexpected reactivity due to their small size. And it can disperse widely in the environment, potentially affecting ecosystems and human health. And existing regulations may not adequately address nanotechnology's unique challenges. And that concludes our discussion for today. Thank you.